Two. It's a continuation from yesterday. And yesterday what we talked about was adding and subtracting fractions, rational expressions. But yesterday, most of what I gave you was common denominator already. Towards the end of the lesson yesterday, we talked about how to find the common denominator if they weren't the same. But today, a lot of the ones that we're going to look at are not going to have a common denominator as we start, okay? And so we're not going to be able to add or subtract them right from the beginning. And so a lot of the ones that you saw in your homework yesterday were pretty straightforward for the most part because you already had the common denominator, so you just add the numerators together and then simplify if you could. There was one yesterday that some people asked me about. It had like 3 fractions in it, but all 3 fractions had the same denominator. So you just keep the denominator the same, add all of your terms on top together, and then simplify it if you can. We didn't really do any yesterday on the notes that had 3 in it, but it's not really any different, just another fraction added in. Same thing's going to be kind of true today, is we're not going to see multiple rational expressions. It's probably just going to be adding, subtracting 2 rational expressions in most cases. All right, I'm going to start with some that just have a monomial as my denominator. And that means there's no plus or minuses in the denominator. We're going to have a plus or a minus in between the 2 fractions. But on bottom, we have an 8u and we have a 12u. It's not u plus 8 or u plus 12. It's just 8u and 12u. And so the first thing we're going to look for today, and we didn't really talk about this yesterday, is restrictions. And when we talk about restrictions, we talk about what can the variable not equal. And we talked about this a little bit last week. But what number can I not plug in for u in this case? What can we not have in the denominator? 0. Okay. So what number would give me 0 on bottom? 0. Okay. If I took 12 times 0 or 8 times 0, then when we talk about restrictions, we say what can u not equal? And u cannot be 0. Okay. And if there's no plus or minus signs, then 0 is usually going to be your restriction. We'll see some with plus or minus signs today, and that'll change our restrictions a little bit. There's a lot of different ways that can be stated, but a lot of times I just use the word restrictions. What is u restricted to be? Okay, so now that's the first thing we're going to start with, and then we also have to determine what the LCD is. And so we're looking for that least common denominator, the least thing that both of my denominators will go into. And there's multiple ways to do this, but one way we talked about doing it yesterday is just listing out all the things that both 8 and 12 go into and finding a common factor. Okay? In some cases, you could multiply these 2 together, but that's going to give me a larger number, and that's not the least common denominator in a lot of cases. And so if I start thinking of things that 8 and 12 go into, what are some things that 8 goes into? Well, we could do 8, 16, 24, and then 12 goes into 24. So 24 would be that least common denominator. Okay, I think that's the easiest way to do it. You could do it by the tree diagram, but I think that's a little bit more confusing, and I think it's a little bit more work. And so I like just listing out the factors of both of those until I find something that's in common. Okay, so there are other ways to do it, but that's kind of the way that I think is the easiest. So I need both of my denominators. They both have a u in them. Okay, so we're going to keep the u there, but we need them both to become 24. Okay, and right now this one is an 8. So what do I have to multiply 8 by to become 24? 3. So we're going to multiply by 3. But if I do it to the bottom, I also have to do it to the top. You can't just do it to the bottom. You got to keep that fraction equivalent. And so I have to do it to both top and bottom to keep it the same. Okay, on the one on the right, we have 12. I want to make it 24, so we're going to multiply by 2 on top and bottom. Okay, so basically everything gets multiplied by something. And so this would become 15 over 24u minus 14 over 24u. At this point, the denominator should be the same. If they're not the same here, then I've done something wrong, because my whole goal is to get these two the same, right? And right now, they are. And if they're not, then I probably did some math wrong or something, okay? So that's the one thing, as you're going through this, that's my goal, is to make those the same. And then it's just kind of like what we did yesterday. Because the denominator is the same, my denominator stays 24u. If you can combine the tops together, combine them, 15 minus 14 is 1. And that's my answer, 1 over 24u. Okay. Nothing we can do to simplify it, nothing we can do. Okay, so that is the first one. Okay, let's look at this one here. 3z over 10x minus 5z over 4x. Okay, if we talk about restrictions, we say what can x not equal here? Because x is on bottom. And as long as there's no plus or minus signs on bottom, then our restriction is simply just 0. Because 4 times 0 is 0, 10 times 0 is 0. So if I plug 0 in for x, it would give me 0. Okay, the other thing we have to do is decide what our LCD is going to be. You guys want me to show you the prime factorization way of doing the LCD? Or do you want to stick with like just finding factors? I'll show you this one and you guys can decide. What does 10 break into? 5 and 2. What does 4 break into? 2 and 2. Okay. And so in order to do the LCD here, we're going to multiply anything they already have a 2 in common, and then we also have a 2 and a 5, okay? So the 2's are in common. I have to multiply anything that happens within these two factors. But I don't have to do this twice because they have that in common, okay? So these 2's are in common, so that's where this comes from. And then I have an extra 2, and I have an extra 5. So that's where those two numbers come from. And if I take 2 times 2, I get 4, and 4 times 5 is 20. And if I listed out the factors of 10, if I listed out the factors of 4. The only bad thing about the list part of it is sometimes you're going to have to list out things for a while. Okay? And some of these are going to be ones that maybe you can even think about without making a list, right? But what I'm trying to get at here is we don't just want to multiply 4 and 10 together, because that gives me 40. And if I used 40, then that is not the least common denominator. It is a common denominator, but it's not the least common denominator. We want the one that's the smallest, okay? So either way, I get 20. I don't know, what do you guys think? Tree, or do you like the list better? The list? I think so too. I think it's a little bit easier trying to determine all the common factors, because sometimes that could get a little bit messy. If you got a bigger number and list out all the factors of what's going on there, I think it's a little bit tricky. Okay, so 20 is my LCD with an x. So 20x is going to be my least common denominator. This one, I got to multiply by 2 on top and bottom. This one, I got to multiply by 5 on top and bottom. Okay. My denominator will now stay the same, right? Do not change your denominator. It's 20x. In order to combine these together, they have to be alike. So both of them have a z on it, right? Sometimes we may not be able to combine these together, but as long as they're like terms, I can combine them. 6z minus 25z. Really watch the sign that's in between. So what would 6 minus 25 give me? Negative 19. Okay, is there anything else that we can do with those? If they had the same variable, I could knock it off. If these two reduced, I could reduce them, but there's nothing else that's going on here. So that would be, all right. Okay, I'm going to do one more here with a single variable. One's a little bit different because it's going to have a binomial on top. Okay, restriction, once again, the variables are going to change from problem to problem, right? We've already seen u's, x's, z's, now we see an m. Don't really pay attention much to the variable. You can use whatever letter you want. So in this case, we're saying m cannot equal 0. On addition and subtraction ones, we always have to have a common denominator. What is the least common denominator? So 2 and 3, this one should be a little bit easier than some. What's the least common denominator of 2 and 3? 6. So my LCD would be 6m. Okay, now this one's a little tricky, okay? And that's why I'm showing you this one. Because on top we have an m plus 8. So on bottom, to make this a 6m, I'm going to have to multiply by 3. Over here, I'm going to have to multiply by 2. But notice what I'm doing here. I'm putting that expression in parentheses because I have to take 3 times the entire top. I have to take 2 times the entire top over here, okay? And if I don't put it in parentheses, I'm going to forget to do the most important thing, which once I see the parentheses here, what's that telling me I got to do with the 3? I got to distribute it, okay? If you don't put the parentheses there, you're going to forget to distribute, okay? Probably the most common mistake made when doing this. So when I write this out, I'm going to go ahead and distribute it. 3m plus 24 over 6m. Okay, and we saw some like this yesterday. Okay, this is another part that gets missed probably more than anything else, especially because of subtraction. When I subtract this, in some cases, I even like to rewrite it like this. I like to rewrite it as a big old fraction. And just put it all into one fraction. Because now this minus sign that was between them has to be distributed. And once again, the most common mistake, and I'll say this a lot over the next week or so, people will subtract the 2m, but then they're going to forget to subtract the negative 14. Okay? If you put it in parentheses, then I think you're going to have a better chance of getting it right. If you don't put it in parentheses, you're probably going to forget to distribute. And that's going to be one of the biggest mistakes that's made. So this would be 3m plus 24 minus 2m plus 14 all over 6m. And then we're going to combine like terms on the top. 3m minus 2m is m. 24 plus 14 is 34. On bottom, we still have 6m. Can I knock the m's out here? No, why not? Yep, this one is connected with the plus sign, okay? This one is not, okay? If it was 34m over 6m with no plus sign here, then I could do that. Yeah. Yeah, I made a mistake adding, didn't I? Yeah, should be what, Jacob? 38, yep. Thank you. 38 right there. Okay, questions on that one? All right, this next one, I'm going to give you a couple of different variables. Okay. Here we have an A and a B. Once again, there is no plus or minus signs. And so we have to restrict A and B here. This is the first one we've seen more than one variable in, at least on bottom. So in this case, because there's no plus or minus signs, then what I'm going to say for my restrictions is I'm going to say A cannot be 0 and B can also not be 0. They're both going to be restricted to not be 0. Because if I put 0 in for B right here, anything times 0 is going to be 0. But same thing if I put 0 in for A. So when I have multiple variables like that with no plus or minus signs, then both of them would have a restriction of not being 0. Okay, LCD. If we list it out, and I think we already had these same two numbers earlier, all the things that each number goes into, 24 would be the lowest, and I could keep listing it out until I found something that works, okay? So we got 24. Okay, now we talked about the variables yesterday, and this is what we kind of talked about towards the end of the lesson yesterday. We found the LCD of the two numbers. Now A's. How many A's would I want for my LCD? Okay, so it's different than the actual number itself. Here I have 2 A's, here I have 3 A's, so I'm going to take the higher of the two. So here if I have 2 and here I have 3, 3 is more than 2, so I'm going to have 3 A's. I need to make A to the third. And if I have 4 B's and 3 B's, how many B's am I going to want? 4. Bigger of the two. Okay. So exponents are different than when it's an actual number out in front. So that's my LCD. This is what I want to make the denominator be. Okay, so we have to force the denominator to be 24, a to the third, b to the fourth. And we got to figure out what we're going to have to multiply to make that happen. Okay, so let's do the first fraction. I have 8, a squared, b to the fourth. What do I have to do to 8 to make it 24? Multiply by 3. Okay, and I have 2 a's, but I need another a, so we're going to multiply by 3a. And I need b to the fourth, but I've already got a b to the fourth. So there, we're okay. And I'm going to multiply by 3a on both top and bottom. Okay, on the fraction over here, we want to make this 24, a to the third, b to the fourth. I have a 12. I want to make it a 24. So we're going to multiply by 2. I need 3 a's. I've already got 3 a's. I need 4 b's, so I need an additional b. So we're going to multiply by 2b. Okay, now this is going to be a little bit more work than the one we did just a second ago. But once again, it's going to be the distributive property. 3a times 2a would be 6a squared. 3a times b would be 3ab. Now, here's what I'm going to show you. Rather than separating them and doing that work and then doing it all together, I'm going to do it all at once. We already know the two denominators should be the same, right? So I'm just making one big fraction here. I'm going to put a minus sign in between. And then I'm going to take 2b times both of these terms. So 2b times a. Now let me ask you this. Does it matter if I write 2ab or 2ba? Does it matter which one comes first when I write ab? No. Okay. So usually what I do is I write it alphabetically so we don't get confused. I put the a in front. If you wrote ba, that's okay. Okay. But you have to understand that ab and ba are the same thing. But if you don't write them the same way, then you may not think they're the same way. Okay? Because think of it this way. If I take 3 times 4 and 4 times 3, do I get the same result? Yeah. So it doesn't matter which one comes first or second, right? We call that the commutative property. 3 times 4, 4 times 3 still gives me 12. So we took 2b times a, and then we're going to take 3b times 2b, which is 6b squared. Okay, now notice I put this in parentheses still, because we have this minus sign here that once again has to be distributed to both. Okay? So if I rewrite the top, is there anything that yeah, go ahead. It should be 24. Yes, thank you. I don't know why I wrote 12. Thanks. Is there anything on top that I can simplify? The ABs, right? 3AB minus 2AB is going to simply make 1AB. Okay. So my answer here, do these three things have anything in common? 6a squared plus 1ab plus 6b squared? No. So that's as far as I can go. So we're going to go 6a squared plus ab plus 6b squared all over and I know in some cases it doesn't really look like it's simplified, right? But in order to take an A out, everything has to have an A. This does not have an A. In order to take a B out, everything has to have a B, but this one doesn't have a B. Okay? And so out of all the ones that we do today, I think that's going to be one of the harder ones just because of all the variables that are going on in there. And it doesn't really look like it's very simplified, but that's as simplified as we can get. All right. We're going to do a few more here. These are going to have binomials in them, and we're going to do some that has some factoring in it as well. I'm going to start with one like this. Okay, so my denominator is a little bit different here. Okay, now we're going to add some addition subtraction signs into the mix. This is still a k. So what number can I not plug in for this single k right here? 0, right? I can't put 0 here because then I would have 0 on bottom. What can I not put in for this k? -2. So here I have two restrictions. K cannot equal 0 or -2. In some cases, we may have 3, 4, 5 restrictions if I have a bunch of stuff on bottom. my LCD. We haven't done one like this yet. These are two different factors. Okay? K is a factor, K plus 2 is a factor. So if I'm asking for the LCD, what do you guys think it's going to be? Jordan? Yeah. It would be K times K plus 2. Yeah. Because they're each separate. And you could multiply them if you want to. Okay? But you don't necessarily need to distribute that through. And here's why you really wouldn't want to distribute it, because these are the two separate factors. Okay? And here's kind of what we did. And we did this the same way on the other problems as well. This one has a K. It's missing a K plus 2, right? So it's got to have both. It's already got part of it. So this one is missing this part. So this is what I got to multiply by on top and bottom. That's the other reason why you don't want to go ahead and distribute it through. Because I'm looking at these two as being my separate. What's the other fraction missing? It's missing a K, right? So I got to multiply this one by K. Okay. What are we going to do on the left fraction? What do you guys think? You got to distribute, right? Keeping K plus 2 in parentheses is a really big deal. Okay, parentheses, I've said it about 5 times today already, just so you kind of get the idea that parentheses are a really big deal on these problems. If I write K plus 2 without the fraction or without the parentheses, I'm going to forget to distribute. Okay, no doubt about it. So this becomes 4K plus 8. I'm not doing anything to the bottom. I'm still not distributing that through. I think it'll be easier if you don't. Okay, up here, there is no parentheses. It's just K, right? So it's just 6K. And once again, K times K plus 2. Okay, my denominator should be the same at this point. If my denominator is not the same, then I've done something wrong. We do not have to distribute the minus sign here because there's no plus or minus sign here. So this is simply going to be 4K minus 6K, which is negative 2K. Thank you. Okay. And a lot of times we'll be done here, but I do want to show you one thing. And you got to check this just in case. As I look at the top, what do these two terms have in common? I got a 2. And not only a 2, I'm going to go ahead and take a negative 2 out. And 8 divided by negative 2 would be a minus 4. Okay, and the reason why we do this part right here is because let's say I get a K plus 2 up here. If this was a K plus 2 and this was a K plus 2, then I could knock those two out. Some cases that'll happen, okay? And that would make it even simpler than it is already. In this case, nothing crosses out, so that's why we'll be done, okay? But if you don't check that, you may not notice that you could actually cross something else out. Okay, questions on that one? A little bit different because it's a binomial, right? Okay, this one is going to have a binomial on both denominators. It's got a w minus 3 over here. It's got a w plus 7 over here. And w cannot be 3 or negative 7. We'll talk more about why we do the restrictions. There's going to be some things come up in the next couple of days where restrictions are going to be really, really important to what we do. It's not as much today because we're not really using those restrictions for anything. It's just saying these are the values that w cannot equal. Okay, the good thing about the binomials here is you don't really have to do much to them. Okay, you don't have to find like a list of factors they both go into or anything like that, like we did on some of the first ones. Here, W minus 3 is a factor, W plus 7 is a factor. So what do you think my LCD is going to be? What if I had just 3 and 7? Then it would be 3 times 7, right? Well, yeah, it would just be these two factors. It would just be W minus 3 and W plus 7. Okay, so whatever's on bottom has to be part of my LCD. Okay, we have 2 separate factors, so they both have to be part of the LCD. This one already has a W minus 3, but it's missing a W plus 7. So this one, we're going to put W plus 7. Over here, we're missing a W minus 3. We got to get both of them down there. Okay, both of these will need to be distributed. Okay, now here's what I'm going to show you. And once again, I think this will save you a little bit of time because these problems are a little bit lengthy. I'm going to make it one big fraction because we know now the denominators are the same. W plus 7 and W minus 3 is my common denominator. We're going to do the top here, we're going to do the top here, and we're going to try to put it all together. So I'm going to take 4 and I'm going to distribute it. I'm going to take 5 here and I'm going to distribute it. 4W plus 5W is 9W. 28 minus 15 is 13. Can we do anything else? Can we knock out W's? No. We got plus and minus signs everywhere, right? 9W plus 13 does not factor. 13 is a prime number. That's all we can do. Okay, we're going to do one more, okay? These were already factored at the beginning. Okay. We can't do the restrictions or the LCD right at the beginning of this one. This one's different than all the other ones that we've done today. Save the best for last, right? What are we going to have to do here? Just looking at the denominators, what do you think we're going to have to do to the denominators? Good old factoring, right? I told you at the beginning of the chapter, we got to have a pretty good grasp of factoring, because if not, this is going to be really, really difficult, right? And I think pretty much every lesson that we've done in chapter 7 has had factoring in it in some shape or form, okay? So it's not going away. We've got to be able to factor. And that's why I've left this up here throughout this whole chapter. It's not going away. It'll stay up here. But we got to know how to factor, okay? We got to know what each one of those methods are. What kind of factoring do we have down here on the left? It'd be DOPS, right? It's 2 terms. It's a binomial. There's no GCF. So what would v squared minus 16 become? You're on the right track.
Plus 8 and B minus. B squared, wait, no, it's not 4, it's 4.
B plus 4. B minus 4. Okay, it is, and I did see that a lot. So when I have 16, I don't just divide it by 2, because the two numbers have to multiply to get 16. So instead of dividing it by 2, we want to take the square root of it. So 4 times 4 gives me 16. Okay, over here, no GCF. It's 3 terms. It's not a perfect square, so we move on down the list, and it's product and sum. So we got to find two numbers that multiply to get negative 12 and add to get negative 1.
Negative 4 on 3.
Okay? All right, so here we go. Restrictions. What can I not put in for V in this first one? Negative 4. What about here? Positive 4. This one's positive 4 again. This one's a negative 3. So here we have 3 restrictions. V cannot equal negative 4, positive 4, or negative 3. We have 3 things V cannot equal. All of those values give me 0 on bottom. We don't want 0 on bottom. Okay, this one's a little bit different for our LCD. Anything that's on bottom at any point in time has to be part of my LCD. Okay, V plus 4 is one of my factors. So V plus 4 is part of my LCD. V minus 4 is part of my LCD. I already have a V minus 4, so I don't need to list it again. Okay, but then I have a V plus 3. So I have 3 factors that are part of my LCD. Okay, and really the question that you want to ask yourself here is, here's what I want, what am I missing? Okay, what factor am I missing down here? V plus 3. Okay, so that's going to be what we have to multiply by. Okay, over here, we're missing a V plus 4. Okay, I'm going to combine these all into one big fraction. Okay, yeah.
Why won't you simplify the right side?
Oh, you could have. Yeah, that probably would make it easier. You're right. Okay, so let's do it that way. Sometimes we can, sometimes we can't. I didn't even pay attention to that. Okay, because over here, if I take a 2 out, we can make it a V plus 3. Okay, and so if I do that, the V plus 3s, and it's going to make it much, much simpler. You're exactly right. Okay. And so, do I need a V plus 3 as part of my LCD in that case? No. Okay, so I really wouldn't need that. I still need the restriction here because it was on bottom at one point in time. So the only thing that I'm going to need over here is a V plus 4. Okay, sorry about this, guys. But it will make a problem a much, much easier problem. Hey, what do you think we're going to do with these two things? Well, and we don't even need to do, that's going to change this too, right? Because we don't really need this. That's why it's going to make this a whole lot easier problem. Okay, so really what my LCD is going to be these two, okay? This one already has both of those. This one is now going to have both of them, okay? We're going to multiply by V plus 4 up here. Okay, so here's what's going to happen. 2v plus 5 minus Okay, what do you think we're going to do next? What do you guys think? Yep, and what do you think we'll distribute? Yep, and we can distribute the 2, but because we have a minus sign in front of the 2, instead of distributing the 2 and then distributing the negative, we could do it all at once. So I could take this whole thing here and distribute it. So this would become 2v plus 5 minus 2v minus 8. Okay, and then these v's are going to knock out. And we're left with 5 minus 8 on top over v plus 4. V minus 4. Okay, and that would be our answer. Okay, let me put these for you real quick. You can kind of see why we split this up into multiple days. There's a lot of stuff in these two sections. Okay, we're only going by 4s today, so you're going to start with 40. And then 44, and then 48, so just add 4 each time. A lot of different types, so just trying to skip and do some of each type through that. So still about the same number of problems, still 9 or 10 problems, something like that. Seems like a lot, but by when you're skipping 4, you're skipping lots of problems.